So we are doing this because we received a lot of queries according to that, especially from the electronic industries, from our electronic customers. So this will be a very short example, just to show you this contact resistance feature only. So the complexity level of the geometry will be quite low, as you see. So as you will see. So basically, let's change the unit system to pound and inch. So I'm doing this at this moment. I'm going to the geometry. So now at this moment you are familiar with this workflow. So let's import the geometry. So we have these two simple blocks. The bigger one represents the PCB, for example, and the smaller geometry represents the chip. Okay, so let's start from the material definition. So we can delete this, and we can easily add new materials, like for example material for the PCB. And for our thermal purposes, all we need is to specify the conductivity parameter and let it be equal to 0.5, for example. Apply, and let's specify the second material, and the value for chip, it will be 144, for example, and let's click on OK. Similar to the previous steps and previous examples, we have to create properties. So first one will be PCB property, and the second one will be chip related. Second one will be related to chip. So I'm changing the material to chip, and I'm pressing on OK. Okay, so we have it. Let's hide all of the guiders. And at this moment, before we mesh the geometry, we can go to the contact, and we can start from the creation of the contact pair. So now I'm clicking on the add, and I'm clicking on the manual contact, and let's select the proper faces to generate the contact pair. So basically it will be welded contact. Now I'm changing the object type to face, and I'm selecting the bottom face of the chip, and I'm doing the same with the upper face of the PCB. So we have this, so I'm clicking on OK, and we can display our contact pair. So as you see, the color has been changed, and this is very useful to locate our contact pairs, especially when we have the more complex model. And let's go to the edit, and let's take a look on the contact parameters. So basically, here is the place where we are providing the thermal resistance, but basically the thermal resistance is a formula. So what we have to use is the thermal conductance as the opposite parameter to the resistance. So at this moment, we will assign the value of, let's say, 1.5. So we have to specify this, and we have to check this contact tolerance option, because at this moment we don't support the offset contact, but we can use this option in terms of generating, of searching the contacting faces which are separated. So in this type of examples, you can use this option, and please change the value to 0.5 inch. This is the distance between the bottom and top face of the chip. Okay, so I'm clicking on OK. Now I'm going to the mesh. I'm clicking on the 3D. We will use the map measure because our geometry is extrudable. Let's say they are primitive blocks, so we can use this, and let's change the size to 0.25. And let's start from the chip. So we can mesh this part as first one. So I'm changing the name for chip, apply. Let's let's mesh the second part, like PCB. Let's click on OK. We have it. And now there is a time to assign the thermal boundary conditions. So in this example, we apply the flux on the top face of the chip. So now I'm selecting this face, and the value, let's say it will be like 10 watts per square inch. And let's add the temperature boundary condition. And I will use all of the nodes from the bottom. And the temperature will be restricted to 20 degrees. Okay? And we are doing the same case. We are selecting the steady state heat transfer. Let's go to edit. And let's change the number of the increments to 1, and model is ready for the analysis, so we can start the calculation. Okay, and now we are able to display the results. As you see, there is a heat transfer across this gap, we can say, and we have the result. Because basically what this parameter is doing, this resistance option allows us to model the thermal effect of the layer, let's say, of material which is put in to mesh in 3D. So this is the example why we are doing this. And before we end this example, there is one. I would like to show you some trick according to the post-processing, especially to the legend. Basically, maybe you don't know, but it's possible to change some parts of the legend. So if you double-click on the color, you can change the color from the legend, and as you see, the model has been displayed in different color. And we have also a command which is called auto range. It's also very useful for the more complex models. And if we add some other option like fringe, we can present the model in many interesting ways for your reports, for your everyday purposes.